On this question, we want to solve the logarithmic equation. Our logarithmic equation is log base 5 of x plus 32 minus 5 equals negative log base 5 of x plus 132. Now, I have two main strategies that I use for solving logarithmic equations. And the two strategies are using the property of equality or to convert to an exponential. When I think about these two strategies, the property of equality, let's write POE, the property of equality requires that I have a log base b on the left and log base b on the right. And when you have that, you can say that m equals n. What's inside the log on the left is equal to what's inside the log on the right. As I look at this example that we have, this minus 5 doesn't have a log on it, and so I'm not going to be able to write log base 5 alone on the left and log base 5 alone on the right. So I'm leaning towards using the other method, which is to convert to an exponential. So when you have a situation where you have log only on one side, you're going to convert that to an exponential equation. You're going to use the base. The base of the log is the base of the exponent. The log always equals the exponent, and this expression will equal what's inside the log. So in order for me to use this method, I need to have a log by itself on one side. And you can see right now that I have logs on both sides of the equation. I can fix that by rearranging the terms. So let's start by doing that. So my equation is log base 5 of x plus 32 minus 5 equals negative log base 5 of x plus 132. So I can move this term to the left. That would bring all the logs together on one side. And I can move this term to the right, getting all the terms that don't have log on the other side. So this would give me log base 5 of x plus 32 plus log base 5 of x plus 132 equals 5. So now I've got the logs on the same side, but I still need to make sure that we only have one log before we do our conversion. So I've got two logs, and I have some properties that allow me to condense logs of the same base. You can only use these properties when they have the same base. So the property that we're going to be using is called the product rule for logarithms, and it looks like this: log base b of m plus log base b of n. So we're adding logs of the same base, and you can condense by using the product of what's inside of the logs, and that's why it's called the product rule. So we're going to condense this to a single log. Both of them have base 5. We'll have log base 5, and inside of that we're going to use the product. We're using the product because this is addition. The product of x plus 32 times x plus 132 equals 5. So now we've got it in a format where we can use this method of converting to an exponential. And when we convert, we're going to use the base of this log. The log always equals the exponent. So 5 to the 5 equals x plus 32 times x plus 132. Okay, so now we have an equation, and we're going to try to solve it. So we need to know what 5 to the 5 power is. That's 3,125. We'll multiply this out and get x squared plus 132x plus 32x. And we need to know what 32 times 132 is. That is 4,224. I'm going to subtract this 3,125 to the other side, and also combine like terms. 132 plus 32 would be 164x. And we need to do 4,224 minus 301.25. That is 1,099. Okay, we want to try to solve this. I can try to solve it by factoring. I need to know factors of 1,099. I've got 1 times 1,099. This is not an even number, so 2 will not go into it. I also know 3 will not go into it because the sum of the digits is not divisible by 3. 4 won't work, 5 won't work, 6 won't work. How about 7? I'm going to try that. Okay, 7 times 157, and that has potential. That's pretty close to our middle term of 164. So let's add 157 plus 7 to see. Yes, so 157 plus 7 does equal 164. So that looks like the factorization that we're going to use. So we're going to factor. We have x and x, 157 and 7. We want both of those to be positive. And then we're going to set each one of these factors equal to 0 using the zero product property. So that gives us potential solutions of negative 157 and negative 7. I said potential solutions because we always need to check to see whether these solutions are in the domain of each one of these logarithms. So I need to go back to that original equation to check to see if x equals negative 157 is in the domain of this logarithm. So we have log base 5 of negative 157 plus 32 minus 5 equals negative log base 5 of negative 157 plus 132, and negative 157 plus 32 will be negative. The log of a negative is undefined. So negative 157 is not in the domain, and we're going to throw that solution away. Then we're going to check the other one, our proposed solution of x equals negative 7. And we would have log base 5 of negative 7 plus 32 minus 5 equals negative log base 5 of negative 7 plus 132. And looking at negative 7 plus 32, that's a positive. Log of a positive is defined. And over here, the other log, negative 7 plus 132 will be a positive. Log of a positive is defined. So negative 7 is in the domain of each of our logarithmic expressions, and we're going to keep that solution. So x equals negative 7 is the only solution to this logarithmic equation. Thank you for checking out my videos. Have a great day.